Mr. Ainsberg here. We're continuing on with the second problem in the 5.3 extra practice with the tree diagrams. Now, in this problem, we're looking at an airport screening bags for its security. And alarm is supposed to be triggered when a forbidden item is detected in that bag. Now, we're told 5% of the bags that go through contain forbidden items. We're also told if a bag contains a forbidden item, there's a 98% chance it's going to trigger the alarm. If a bag does not contain a forbidden item, there is an 8% chance that it will trigger the alarm. We're asked that if we're given a randomly chosen bag, that triggers the alarm. So given a randomly chosen bag, that triggers the alarm, what's the probability it contains a forbidden item? So state, plan, do, conclude. The 4-step process we're going to be trying to do a lot more. So state, what am I trying to find? I'm trying to find the probability given that the alarm goes off. Given that the alarm goes off, it contains a forbidden item. That's what I'm looking for. Now, what's my plan? My plan is to create a tree diagram of this situation and use that to perform the calculations to get my answer. So, plan. Well, you're going to have people, and those people are going to pack their bags before they go to the airport to go on their trip. So the reason why I say it that way is because when they're packing their bags, before they even get to the airport, they are either packing a forbidden material or they are not packing a forbidden material. That event occurs before they walk through the detectors. So you need to put it in the diagram before the detectors. Now we're told 5% of the bags contain forbidden items. So right here is 0.05 and right here is 0.95. And we're good. Now, what happens next? They get to the airport, they get in line, then they go through the detectors. And when they go through the detectors, you're either going to get an alarm or you're not going to get an alarm. And the same goes down here. So now they go through the alarms. Now we're told if a bag contains a forbidden item, there is a 98% chance that it triggers the alarm. So that 98 is it contains a forbidden item. There's a 98% chance it'll trigger the alarm. So using the complement rule, there's a 2% chance it won't trigger the alarm. If a bag doesn't contain a forbidden item, there's an 8% chance that it triggers the alarm. And so that would go right here. It does not contain a forbidden item. It's got an 8% chance. So again, the complement rule tells me this is going to be 0.92. And what I can do is follow the paths and get all my probabilities at the ends of the branches. So let's do do the multiplication there and figure it out. And magic, they're up above. So let me write these down. So I followed the paths, and we'll do this. We have 0.049, 0.001, 0.076, and 0.874. Now again, remember what those mean. That 0.049 is the probability of forbidden and an alarm. The 0.001 is forbidden and no alarm. And I say that because we are still trying to answer our question. The probability of a forbidden material given that an alarm was triggered. Well, that's going to be the probability of forbidden and an alarm over the probability of an alarm. Using our conditional probability definition, that's what we're looking for. So the probability of forbidden and an alarm, that's right here, 0.049. Now, what's the probability of an alarm itself? Well, we have two alarms going off. Well, that's right, we have two chances where alarms can go off. One with forbidden and one without forbidden. And so I could have it here and here. I mean, that's where alarms are going off. So I'm going to add those two numbers together. I'm going to do 0.049 plus 0.076. So again, I'm going to use the calculator, and I know I have it still now in the new mode. So 0.049 on top, 0.049 plus 0.076 on the bottom, and that is a 0.392. So it's approximately 0.392. So what is the probability that you have a forbidden item given that the alarm goes off? It is 0.392, approximately that. Now, isn't that interesting? And again, we had this discussion at the end of the previous question. Given that the alarm is sounding, the probability that given that alarm sounds, that a forbidden item is in the bag is 0.392. Now, that's an interesting probability. So, and I say this just because when you hear the news or you read articles or along these lines, you hear these probabilities. A 98% chance, if the bag contains an item, there is a 98% chance that's going to trigger an alarm. That sounds high, and that is high, and that's good. But you need to realize probabilities with all the possible outcomes under conditions, you start to see the real probabilities behind the scenes. And it was the same situation with the drug testing. 1% for either a false positive or false negative or along those lines sounds low. But then when you put it into the probabilities with the conditions, you start to see the true probability outcomes over certain events. So this is a very interesting concept with the tree diagrams. Hopefully this helps you. The main idea is to understand how conditional probability works in a tree diagram.